And right, the triangle inequality. So if we have two elements of this metric space, we can always find a third element. It doesn't matter too much what it is. But for any other element, this will be true. And this is kind of a generalization of the triangle inequality in Euclidean space.
What
Well,
is
you forgot one that
Right.
x is 0. Or you could say if and only if x is equal to y.
Sure.
If x, y is 0, if and only if.
Right, so the distance of a point to itself is 0.
what is set B? Is that in Rn dimension or just
No,
have to be
an arbitrary set.
Arbitrary.
Metric spaces are defined very generally. We can get them, and maybe we'll go into this later, but we can get them from normed spaces. So any vector space where a norm is defined, we can take the norm of x minus y and set this equal to the metric of x and y. And this is called the induced metric from the norm, right?
And those are called balance spaces.
As long as Cauchy sequences are complete, right? So, yeah, we'll discuss the Knox spaces later, I believe. Where was I going? So anyway, what he discusses, and I'm not going to go into any more details here for a couple of reasons, but he discusses a contraction mapping and an operator on metric spaces, and he discusses that if we treat this as an operator on this metric space, that sort of shrinks the distance between yk and yk minus 1. If this operator applied to these vectors sort of shrinks this distance each time we apply it, then it's a contraction and it has a unique fixed point. And he proves the contraction mapping theorem and then applies it to this problem with this being the mapping, this yk being the mapping of the element. So I think that's all I'm going to discuss today. What did I do in time? And then Adil will, so what we're going, I guess what we need to talk about is what sort of book to work from, because there, I don't know, I sort of mentioned other people, we could look at other things, and it hasn't been set in stone that the Michael Taylor book is one we will look at. So there are several other choices. One that was suggested to me by two different people is Lawrence Evans. One problem with it is we do not have online access. Everyone here has online access through Springer to the Michael Taylor book. But I can kind of give you my interpretation of the difference of these two, and then I can be corrected as I'm wrong. This book, the Michael Taylor book, is far more geometrical and very sort of invariant, talking about differential forms and trying to put these operators in that language, whereas this book is, as far as I can tell, only in Euclidean space. So in some sense, this might be more interesting to anyone interested in mathematical physics, and in some sense, this might be more interesting to people who want to do more, I guess, applied things. That's not necessarily true, but that's sort of how I was told it by Dr. Kerr. So this book, from what I can tell, personally speaking, this does not mean it's the case, is easier to read and kind of picks up where 438 left off, the second PDE's course, whereas this book is quite a bit at a higher level, much more general, much more theoretical. So it's good in its generality, but it might be hard to really understand anything after we get out of chapter 1. But I don't know, what do you guys think?
Good so far. I mean, I'm not sure the books. I don't really have any input on those, but I don't know. It's presented very well, at least the way you're presenting it. But
Why don't we study that? Because the general things like most of people know the notion and are really interested in the theories for the mathematical physics. But yeah,
the book is openly accessible. I mean, that seems like a bit of a plus.
Right. Anybody else? So one thing I can suggest is for next week, Adil, I think, wanted to volunteer to pick up where I'm leaving off.
Are you
Okay.
stopping now? Or you have another half an
Well, I
hour?
thought we would discuss this more. I have a little bit more, but I'm much less prepared to give it. I
Why
can,
don't you do that? I mean, it would be fun to see what,
Sure.
how do you sound when you're less prepared. Well, let me say a couple of words in these
Sure.
books. Well, I have both of them. Well, I like the Taylor's book way more than the Evans book, and so I like it very much. It's a fundamental kind of treatise. It has 3 volumes, it has everything in it, and it gives a very good preparation, like for the whole, what follows. And, well, the idea of this seminar, I guess, was to get some exposure and to some experience and to get excited. And don't expect that you will know that stuff. I mean, for that you need to take a course and to study that book thoroughly. So, and for that, this book is good. I mean, you don't need to understand all the theorems, and whoever will present next stuff, I mean, you just need to explain the ideas and what's in there, and you say, okay, here's the theorem, and I'm really not sure how to prove it, but I mean, they use this and that. That will give you a lot, much more useful than spending, you know, months on some proofs that you'll never really see, and it even may kill your interest in that thing. I mean, because you'll be buried in the technical details. That book is, as I said, it's much more geometrical. It has a Hamiltonian system. It has symplectic geometry. It has vector fields. It has a completely integrable system, all already in the first chapter. So it's a, well, it's some people would ask about, like Adil was asking about those things. It's already here. This basic gives you kind of an idea what comes next. And then, well, you have everything. And those, if you want to go into depth, then there are some appendices, or you could consult some, I don't know, faculty, it could come to me, or, you know, but I really think that most of the people would benefit from this seminar much more if you use that book.
Sure.
Well, there are thousands of books. It's a very old subject, and that book is much more modern. In particular, in the second volume, there are applications and some really exciting stuff that, I mean, this is just a classical PDE book that, I mean, if you go, I don't know, 60 years ago, it would look exactly the same. It is that subject. Whereas Taylor's book uses some exciting new stuff as well.
right.
It's just written very differently, and also it has very nice set of problems, exercises, and some of them are real. I mean, I would advise you to do. I mean, in particular, even in this basic chapter 1, like things related to linear algebra, determinants, exponential matrices, and operators, and Duhamel principle, and a lot of things, very, very useful and used everywhere. Nice selection of exercises that some of them you could do in class. And it is great.
So I think maybe, I mean, if this sort of sounds like a good idea to everyone, if we continue with this book, and then if someone wants to present but they don't feel comfortable with it, they could pick something from anywhere